which in a couple of years will go into the Earth.
Well,
Because
it's your opinion, but what do the math show?
Yeah, so I've seen a video which shows on programs which simulate the free things problem, because the Newton, when he wrote the theory, he already identified the free things problem. So you cannot have you. So that theory says that you cannot have a free object orbiting in a non-symmetrical orbits for a very long time, for a thousand of millions of years. So
why not? I've never heard that before.
So basically, there's a problem with Newton's law of motion, and when it comes to three bodies in motion in orbital mechanics, and this was a limitation that we have. That's why we tend to invoke Kepler and Kepler's laws of motion when we're looking at orbital mechanics. And Kepler's laws of motion happily predict what we see regarding the moon. In fact, it actually predicted the fact that the moon should be moving very slowly away from us. Which it is. So I don't see why it would need to be an elliptical orbit either, because otherwise we would see that effect on every single planetary satellite that we observe. So no, I can see kind of where you're going, but I'm fairly certain that you go beyond Newton as far as I understand it, and you start using Kepler because he can describe these multiple interactions on a singular body. And the only reason I know that is because you said it's the three body problem, and that's something I remember reading about maybe 20 years, 30 years ago.
Yeah, but anyway, if the things like moon are orbiting around the Earth by formula, right? And there is a equilibrium between the centripetal force, which is the gravity, and centrifugal force, which is given by the velocity of the satellite, right? So if we got the calculation of the attraction force between the moon and the Earth, and then we calculate the force between the moon and the sun, we will realize that when the moon is going between the Earth and the sun, so like when it's solar eclipse, the gravitational force between the sun and the moon, it's double than the gravitational force between the moon and the Earth. So even if the moon is closer to the Earth, but if the force of the sun it's double, the moon should go a little bit straight, right? So making like in every cycle, making the force of the sun attracting the moon, it's double than the force of the Earth. So this should be a massive deformation of the orbit, in my opinion. That it's only my opinion.
Show us the maths.
What about all the mass that's away from the sun on the opposite side?
Now I've done the math.
Have you factored
before? You can done it. You can done it. It's the force, the gravitational force between the sun and the moon. It's twice than between the moon and the Earth. So, as I got by now, the officialist claiming that there is a Hill sphere, right, which says inside of the Hill sphere of the Earth, the sun is not affecting, but that is contrary to the tides explanation, because we got a moon tide and we got the sun tide. So you know guys about the Hill sphere, which is like an imaginary sphere of any planet?
Yeah. You're talking about the gravity well of the planet.
So that's the explanation why the moon is not being affected by the force of attraction of the sun, the Hill sphere. So I don't agree with that Hill sphere.
So just because the person doesn't agree with something, does that mean it's wrong?
No, I just show up my opinion.
I think he's giving his opinion, and I think that's fair. And I think it's an interesting question. And I'm not certain off the top of my head I could give an answer. But I don't think it's a bad question, actually. I think it's about the best question I've heard this week.
Ross, you are coming in quite low. Can you step onto the mic a bit?
Sorry, I have my head out the window and I forgot I wasn't wearing the headphones for the mic.
Yeah, that's better.
Yeah, I was going to say, I don't think he's making an assertion. I think what he's doing is he's trying to justify, or he's trying to reason behind his claim. And I think it's an interesting question. I think it's one of the better questions we've heard this week, to be honest.
Guys, yeah, exactly. I'm not claiming anything. I'm just doing questions. So
okay, I have to apologise. I had another power cut. The stream went down, but it is now back up. I have a question from the chat from Carl Christofferson. He would like me to ask, could the panel talk about the twin experiment? I have no idea what that is, so apparently that's psychology, not physics.
Could you repeat twin what? What so experiment?
The twin experiment is basically if I'm on Earth and I have a twin, and that twin moves away from me at the speed of light to go and say visit Alpha Centauri. There's going to be a difference in the time that he experiences versus the time I experience. For him, it's about 6-7 years of span going by. For me, it's more like 50 or 80, I think. And this is the time dilation paradox, where we normally, under traditional physics, we treat time as a constant. In an Einsteinian physics, time is a variable. That's how I understand it. Whether I'm right or wrong, I'm not sure.
Essentially, that's correct. And an interesting bit of trivia about that, on the song by Queen on the album A Night at the Opera, the song is called 39. That song is about the time dilation.
Well, it would be with the one with the big frizzy hair being a now full PhD.
That's Dr. Brian May.
That was it. Thank you for fixing my memory.
And on a totally unrelated pop topic, the Jam wrote a song called "Going Underground." That song was actually written as a homage to a 2000 AD comic strip called Nemesis the Warlock. There you go. That's how you stop a conversation.
Because knowledge is power.
We've had a lot of background information and weird origins on this panel so far.
Well, of course, we've got a wide number of people here from all over the globe, with a very diverse background.
Not all over the globe, all over the pizza.
But I've measured the bit around me for about 300 miles, 450 kilometers, and that bit is definitely curving with a curve that has a radius that is approximately 6,374 kilometers.
Oh God, I just thought about it. Thanks to the invention of supermarkets, If we are a pizza, we're a Hawaiian because there's pineapple everywhere.
Oh shit.
I've measured my local bit, and I know people who've measured other local bits that overlap up the east coast of the United Kingdom, and all of those bits also curve on the same radius on the same point of origin. So at least the east coast of the UK and the waters around it are most definitely part of a sphere or spheroid.
Okay, so I've got a good citation article for the moon and the sun. So the short answer is because the moon is much closer to the Earth than it is to the sun. This means the gravitational acceleration of the Earth towards the sun is almost the same as the gravitational acceleration of the moon towards the sun. The moon's acceleration towards the sun, and I can give you the formula if you're really interested, is indeed twice that of the moon towards the Earth. This is irrelevant. What is relevant is the moon's earthward acceleration due to gravitational compared to the difference between the moon and the Earth's sunward gravitational acceleration. Another formula. This relative acceleration towards the sun is a small perturbation of less than 1/87th in magnitude on the moon's gravitational acceleration towards the Earth. Given the current circumstance, the sun can't pull the moon away from the Earth. And then there's a very long, in-depth answer that follows on to that. Would you like me to pop that in the link for you I got so you can have a look at it yourself?
Sorry, are you talking with me?
Yeah, I just found a really good explanation of why the sun doesn't pull the moon away from the Earth.
All right.
I mean, the other thing as well, that when I was reading a few other citations on this, when you were doing the maths to calculate the gravitational pull, were you doing that from a straight line or a concave? Because obviously the moon has a concave relationship to the sun from the point of view of vector mechanics. So it's a greater maths way beyond me, I will be honest. I probably could sit down for probably a day and work through it. But it's not something that is naturally part of my maths is more towards statistics.
No. Well,
it's an interesting citation, so I'll post the link anyway, just so you've got it.
Okay, post it. But anyway, I'm not a scientist. I'm not mathematics.
No, I just thought it was a really good question, and it was a question that was worth looking into. And that's actually nice. It's a question that isn't being asked 20 times a day by, the same people that have been answered thousands of times. You've actually come up. So that's why I'm trying to say it was a good question. I'm trying to be nice.
Well, on my opinion, right, because I was a NASA lover, let's say a heliocentric model lover, right? And I was imagining how the planets are evolving and all this stuff. So when I'm doing it now, I realize that the sun and the earth could work, right? Or two objects with the same mass, they can orbit together around a imaginary center forever, right? But when you put a third object on the system, from my point of view, from my actual point of view, I see that it's all going to end very quick, because when the moon passing between the Earth and the Sun, if it's attracted with a bigger force, the trajectory will not be the same orbit. It will be deviated in every cycle.
Well, no, that's assuming that the force of the pull is greater than the velocity of the orbit. So you're only going to change that vector of direction if you apply the appropriate amount of force to actually shift the mass. That's why, yeah, I kind of agree. Orbits in our solar system do change and will change. That is something that we recognize. That's why we have rogue asteroids and we can't predict where everything is, because of these multiple pulls. But for the amount of mass you've got to move at the fucking speed that it is moving at in relation to the object that it is orbiting, yeah, you're talking minute changes. You're not talking changes that are going to introduce a very strong ellipse, because you would need a huge amount of energy, of force, to be able to do that.
And there is a way in which you can have perturbation throw things out of orbit. If the frequency of the pull and the frequency of the disturbance align with each other, you will get a harmonic. And yes, that will throw things out of orbit. But those are actually known and explained and observed phenomena. There are places in the solar system where an orbit is impossible, because the rotation of an object in that place would coincide with, let's say, Jupiter's orbit, so that they align every time when the object is at its most distant from the sun. And then it will get a little bit more distant, and next time a little bit more distant, and it will get thrown out. And that's why you have the bands in the holes in the rings of Saturn, for example, because places where that resonance happens between the gravity of Saturn and the gravity of its moons makes it impossible for anything to orbit there. But that is not everywhere, right? As long as they're not in a harmonic, those effects eventually cancel each other out, and you get the approximate orbit that we do see.
Oh, yeah. How I see the things is by an equilibrium. So to the moon can orbit the Earth. I see an equilibrium between the centripetal force, which is gravity, which we can calculate with the formula, and the centrifugal force, which is toward outside. So when those two forces are equals, there is an equilibrium, and the satellite could make a circular or elliptical orbit, right? But in our case, the moon is pulled by the Earth toward the center of the barycenter, right? And at the same time, the moon is pulled toward the sun. So in my view,
But here's
the
where
orbit of the moon will be this going slowly to the sun. I mean, the Earth
if the sun was in a constant position relative to the moon, that would be true. But as the moon orbits the Earth, the sun changes its relative position to the moon. So it's pulling him in one direction in one position, and in another direction in another position. And while the whole circle is completed, those pulls all annul each other. And the effect that you have remaining is that the barycenter of Earth and the moon is orbiting the sun. And
I think
Earth and the moon are orbiting the barycenter.
I think what he's leaving out is he thinks the moon is being affected by the sun's gravity, but he's ignoring the fact that the Earth is also being affected by the sun's gravity.
And that's why I read
Yes.
out the article, because obviously, the acceleration of the Earth towards the sun versus the moon towards the sun there's such a fractionally small difference.
Yeah, but I got it. But the for example, the Earth is affected by the sun's gravity, but the Earth is got a velocity. So the velocity is proportional with the distance, right? So when we are in January, right, is the perihelion, I think we are 4 million kilometers closer to the sun. So we're going faster, right? So the velocity of the Earth around the sun is continuously changing, right? So the moon is going with the Earth, and
because the same forces are being applied to both bodies.
right. But the problem is that the moon, in every cycle, I mean, the Earth is staying on the orbit, but the moon is going.
No,
Every
the Earth.
cycle.
The Earth. Wait. The Earth is not staying on the orbit. The barycenter is staying on the orbit.
Yes.
Okay.
Right.
Okay. The barycenter, right?
And if you think about it, you just mentioned, you know, our orbital apogee to perigee difference is about 4 million kilometers. Yeah, and that's pretty cool. Now, what is that of a fraction of the distance that the moon orbits the Earth compared to the distance of the barycenter of the orbit of the Earth and the moon towards the sun? And you start looking at these in fractions, and then you start to apply the inverse square law for the effect of gravitation at that distance versus the solar mass. And you can see that the difference of effect that you'd have there is probably not enough really to fuck with the mass of the moon. The moon is actually quite a large object. You know, we kind of lucked out. We got the cute chick from the moon school of dating. Compared to most other planets, you know, we batted well outside our league for the size of planet we are to get such a cool moon. So that, you know, I still am not seeing your argument from that point, because I'm thinking of the barycenter, the orbit of that barycenter, the masses of the objects in that orbit, the distance of that from the sun, the mass of the sun versus its gravitational pull, and what that difference would make to the orbit of an object that has a velocity going around Earth anyway in that orbit. So I'm not saying I'm not buying it, I'm afraid. I guess is what I'm saying.
Yeah, if you let me explain, I apologize for my English. So the barycenter of the Earth moon. So
you speak much better English than I speak Spanish.
So the barycenter of the Earth moon system, it's below the Earth surface, about I think it's 1600, something like this. So to the center of the Earth, it's 6300. So we got a deviation. I mean, it's not centrical, the movement. I mean, the Earth is got the center of the Earth is got a deviation from the sun, from the orbit, just about it's 3,000. Let's say 4,000 kilometers every 28 days. So it's a small amount. But the moon, what I'm trying to say, it's the moon. Yeah, the moon. It's going 800,000 kilometers every month. So it's a big variation on the attraction, right? Just to go into the extreme,
because again, you got to look at the inverse square law and the difference of that attraction between the mass of the Earth versus the mass of the moon versus the orbit versus the attraction of the sun. And I'm not seeing a problem with the maths. You know, they recognize there is a perturbation. And
yeah, my point,
perturbation, which is not going to have the effect that you want it to have. Even, you know, as I say, we know the moon is moving away from the Earth, so that, you know, we are seeing an effect, but it wouldn't cause an elliptical orbit. It might do when it gets out further, but not now.
When you say we know, so I'm not agree, because
that was kind of strong. We have extremely good evidence that indicates. I'm trying to keep my language straightforward. But you're right. That was a good thing to pull me up on.
I would say this way: we understand it well enough that we can simulate it, that we can do a detailed simulation of how these objects should move, based on just the laws of physics that we know. And these are the simple laws. These are the like by Newtonian mechanics, and you can model that. I've literally written such a simulator live on Sean G's in JavaScript, and it shows you that yes, there is no problem. Those forces do cancel out, and you have a stable orbit the way that we predicted. And if you set up your conditions such as they match what we observe, then you can project it backwards and forwards in time and get exactly what we observe. You can measure it a week from now, a month from now, 10 years from now, like thousands of years from now, and it will still align with the model. There is no like the fact that you do not intuit that the fact that you intuit that it should fall apart, and or the fact that you intuit that we need further information to stop it from falling apart is just wrong. What we know now, what we have known for 300 years, is entirely sufficient to predict what's going to happen and to explain what is happening without any anomaly, without any problem.
I think the thing I point to that is, wasn't the discovery of Uranus or Uranus,
Neptune.
Was it Neptune?
I think it was Neptune.
And I know they predicted it, and they literally found it within, it was either a month or 3 months. It was really, really quick discovery when you compare it to the predictions for Pluto. And that was purely done based on our modeling of the solar system and going, hold on a second, that doth not look right, sir.
No, you were right. It was Uranus.
Okay, sorry. And to me, that's a great example that what we have is actually working, because it not only allows us to predict where shit should be.
No, I was right. It was Neptune.
You're just teasing me, Barney. Thank God I didn't say anything cocky.
Go ahead. Sorry.
But yeah, but that discovery to me is, it wasn't the fact that it was not just the fact that we can predict the orbit of planets. We actually spotted a problem, made a prediction, which then gave an observation to discover a new planet. And that was all based on the modeling of how the planets operate in our solar system. Sorry, that was very long-winded, and I didn't mean it to.
Yeah, that was fine. There were, at the same time, there were two problems. One problem was the orbit of Uranus, which was irregular, and on the other end of the solar system, it was the orbit of Mercury, which was irregular. Both of those orbits had solutions like that. So, in the same way that Neptune was posited, so was Vulcan, right? As there is a planet which is so close to the sun that it is exerting gravitational force on Mercury and causing it to precess, but we cannot see it from the glare. One of those, or both of those, had two possible explanations. Either we got gravity wrong, or there is an object there. In the case of Uranus, in the case of Neptune, we calculated where the planet should be and looked for it and found it, literally where it should be by gravitational. So that confirmed the Newtonian gravity and discovered us a new planet. In the case of Mercury, we looked for Vulcan, didn't find it, but ultimately Einstein came and described by general relativity that close to the sun, the gravitation of the sun, the distortion of space-time literally changes the passage of time for Mercury. Time is passing slower on Mercury, and its orbit is acting accordingly to a slower passage of time.
Scary shit.
I think it's kind of exciting, personally.
I love it. I mean, I mean, considering really, the whole reason I came on into these hangouts was never to discuss flat Earth. I was here to talk about history and archaeology to people like young Earth creationists that kept representing carbon-14 dating so poorly.
Surprise!
And then people kept asking questions I wasn't confident of the answers to, and that fucks me off. So yeah. And I quite like maths and physics.
I know. Whenever somebody asks you a question that you don't know the answer to, that is when you learn something. You go and read up on it and look it up, and then when it doesn't make sense, you try to work it out for yourself and figure out who got what wrong.
Sorry.
It is very, very rare that I come to the conclusion that I was right and science is wrong, the overall science, and very, very predominantly, it turns out that I got something wrong, that I misunderstood the meaning of a term or the implication of a fact.
Yeah, no, I totally agree with you. It's the same way. I mean, on my desk at work, I've got a little sort of plaque which I love. I mean, it's kind of like my mantra. It's I never lose, or I either win or I learn.
Yes, that's an awesome plaque. Yeah, I agree with that wholeheartedly. But it is literally the principle of, if we disagree, then one of us is wrong. At least one of us is wrong.
Exactly.
If I show that you're wrong, then I have corrected a wrong in the world and made the world a better place, so I win. If you show me to be wrong, then you have made the world less wrong, and I am grateful to you for showing me to be wrong, because I have learned something, and I win.
That's like the Uranus Neptune thing. I mean, I would have been happy if I was right. I was equally happy you were right, because now I can correct something in my logbook.
Can you though? I've said 3 different things about a binary choice.
True. I mean, I'll double check, but I doubt you didn't not go and actually check how they found Neptune. And I know I've got the story right. Maybe I've just got the planet in the story wrong.
Uranus is the 7th planet. Neptune is the 8th. Therefore, Neptune is the one that they discovered.
And Pluto is the 9th. I don't care what they say.
Well, if you're going to count in Pluto, then Pluto is the 20-somethingth.
That's always the problem, isn't it?
Pluto's the 9th.
I know, but
Pluto would still be the 9th, but there would be 20 odd some others as well.
That's right.
Well, it wouldn't, because Ceres would then be a planet, because it is not as large as Pluto, but it is large enough to be spherical.
Yep, and it has an atmosphere. Not much of one, but it does have one.
I think Pluto is, even if they don't recognize that planet, it's got 2 satellites.
It's got the coolest named satellite in the solar system, which is Chiron. Can't remember what the other moon's called.
Cerberus.
Of course it is. How stupid.
That's what I like about being around here. You learn stuff.
By the way, I was joking when I said Cerberus. I hope nobody took that seriously.
I don't know, so I'm going to go and check it out.
I didn't even know Pluto had 2 natural satellites.
And Cerberus was the mythological three-headed guard dog.
Yeah, I know
Holy
that.
shit! There's 5 of them,
Yep, I was just about to say that.
and one of them is Cerberus.
Yeah. You got Nyx, who's goddess of dreams, bad ones generally. Hydra, obviously the multi-headed serpent, and Styx.
Oh,
Good
so
band.
all Greek underworld then.
Well, no, the Hydra really isn't. I think they just sort of ran out of names. But obviously Styx and Chiron kind of go together quite well. Nyx is one of the chthonic gods. So
But they did maintain that creepy theme.
Hydra's. I'm sure Hydra was. Wasn't Hydra the one with the snakes for hair?
no, that was
No, those are the Gorgons. You're thinking about Medusa.
Yeah, the Hydra, you'd cut off one head, 2 more would sprout.
Yeah. So the Hydra was killed by
Heracles.
Hercules and his helper Diomedes, because it was Diomedes who suggested he burnt the heads with the torch, and that's why when he went back to the king, who fuck knows what his name is nowadays, that's why he had to repeat a certain number of the tests, because he was only supposed to do 8 labors, but ended up doing 12 because he fucked her out. So the cleaning of the stables, for instance, that was another one that was not allowed to count because he used a river. He didn't do it himself. Sorry. I'll stop because I can do this for an hour.
Yes, the stable was cleaned, but he failed to show what was his independent variable. So Riley didn't accept the result.
Anthony Riley. Oh dear, Anthony, you do know it all ends rather badly for you. Because I'm not sure, but wasn't the king Sisyphus?
It wasn't Sisyphus.
Oh, I hope it was. That would be so funny.
Yeah, Sisyphus got a job as a stonecutter's helper. Rolling the stone forever and ever.
Oh yeah,
Never mind.
No. You were bang on the money. Actually, I just didn't know where you were taking it.
Yeah, just a joke. Of a stonecutter's helper, the job never ends.
Rolling.
Just so we don't get onto 70s TV programs again.
Yeah. All right, what's your next question?
Oh no.
King Eurystheus.
Eurystheus.
King Urethra, what?
My next question.
Sorry.
Do you have any questions for me? Anyone?
Do you have any answers for us?
Yeah. Well, depends on the question. If it's about my model, which is my model, well, I think the Earth could be concave, but it could be flat. So I really don't know.
How are you aligning that with the optics of what we see? How does
And
reflection work in your universe?
The way that could be a ball, so we are in the top of the ball, it could be the Ptolemean model, which is the Earth is stationary and all the other stuff it's involving around us. So I really don't think the Earth is spinning.
There is a problem with the Earth being stationary and the rest of the universe revolving around us. I think you would still be in the solar system by the point in time of which the stuff going around us would have to reach the speed of light.
Yeah, but that is in the case of the distances.
Well enough.
in the case of the distances are real, so light years, right? But in a smaller model, it could be possible with a smaller sun.
Okay, how do you then account for the parallax of things
Sorry?
within the solar system? How do you then account for the parallax of the things within the solar system?
The parallax, you mean the way for measuring the distance by two observer on different
Yes.
points?
Yes.
Yeah. And
because
Alright.
things in the solar system are close enough that we can bounce radar off them, and we
I was
can
about to
see the
say that.
parallax in them, like by conventional measurements. You don't need something exceptional and extraordinary, and all the ways that we can measure them agree on the distances of the planets.
Right,
Also,
but
I would,
that parallax is based on a supposition, and that supposition is that the light is traveling straight. So I think there is no experiment which confirm that the light is going straight on horizontal, but I think it's going straight upward. But we don't have any experiment that prove that the light is going straight. I think the light is bending upward.
The light is bending downward based on in the atmosphere, based on the known density of the atmosphere and the laws of refraction.
Yeah, the official version is the light is refracting downward, is bending downward by refraction.
Yes.
But even so, I think even with that tiny bending downward, there is another bending upward, which causes a result of a 15 centimeters per every kilometers upward. There is an experiment performed by a German in 2005, I think. The German is his name is Wilhelm Martin, and he was doing the experiment in 1 kilometer with a theodolite, and the result was the average bending upward of the light of 15 centimeters per kilometer.
What was the guy's name?
Wilhelm Martin. 2005, I think, was the performing the experiment. I want to repeat that experiment, even more precise, on the side of a canal or something.
When was the experiment performed?
In Germany.
When?
2005. 2005.
The guy died in 1954. No, sorry. That's probably different. Wilhelm Martin.
Maybe it's another Martin.
Do you mean William Martin?
Wilhelm Martin, I think. Anyway, I can check it, because the experiment is on the page Wild Heretic.
Yeah, I'm just looking at that page now.
If you got Wild Heretic, Wilhelm Martin, you just put Wild Heretic Wilhelm Martin on Google, and it will send you to the Wild Heretic web page.
I will definitely take a look into that.
Okay, because on the so everything I say, it's by the point of view of the questioning, not claiming anything. So on the concave model, which I think it is, I'm not sure, I don't know, nothing. In the concave model, the light is bending upward, right? So it's bending so tiny amount that we are not aware. So basically it's bending twice of the curvature of the Earth. So if the Earth, the water in the official model is dropping 8 centimeter every now. And in the first kilometer, the light is bending upward the double, 15 or 16 centimeter. On the second kilometer, if the water, the earth is dropping 32 centimeters, the light is going upward the double, which means 64. Right. So the light in the concave model is bending by like a parabola, right? So hitting the celestial sphere on at 90 degrees finally. So I don't know that. I just explained the theory on the.
And can I ask can I ask a question here? How big is this? How big and curved is this bowl that we are in supposed to be?
It's the same
Or
distance.
or are we supposed to be on the inside of a sphere?
Right. It's the same distance as the official sphere. So 13. I think it's 13,500 kilometers in diameter.
And it's so. Although you say concave, what you actually mean is that we are on the inside of a sphere.
Right, because concave, you can get a spoon, which is concave, but it's not a sphere. So we are inside on the concave side of a sphere. We got poles, we got everything what we got on the outside of the Earth, but the sky it's on the middle. It's on the center. It's not on outside.
Impossible, because radar wouldn't work. Radar would show us that it is curving, because radar would show us the curve because VHF and microwave frequencies are refracted far less than light is. So they will not follow this same line that you are claiming light does. Those electromagnetic transmissions would carry on going in a straight line.
On the concave Earth, every electromagnetic wave is bending upward, just like the light does.
How?
So,
using what process?
I've just told you that there is no proof. There is just an experiment, which is a clue.
Because other than gravity, the only thing that can cause light to be bent is refraction.
That we know of.
That we know of. The only two things we have found that will curve like well, sorry, there's 3 if you count diffraction as well, but refraction and gravity are the 2 things that will bend light in this manner.
Yeah, but
we have found nothing that will bend radio waves in this manner.
Yeah, but the when you say the light is bending by gravity, do we have any experiment doing on Earth,
Yes.
or we just?
Yes, there's the 1919.
I think that was May 30th, May 29th of 1919.
Yeah, but the observing the sky on the solar eclipse, there is no experiment. It's just an observation. There could be any lens
No, the experiment was the fact that you're making a prediction about what you should be seeing. The observation is the realization of the hypothesis to either affirm it or deny it. And then you can then say there's a correlation between the hypothesis and the observation.
Yeah.
Well,
and by the way, I have also done lots of experiments trying to bend radio waves with all sorts of things, and none of them worked other than using refraction. I worked for 9 years.
And if you're going to try, and you cannot try to invalidate observations with a declaration. To do so invalidates 90% of medical sciences.
Yeah. See, the thing is that I spent 9 years as a radar technician, so knowing what microwave radio frequency does is kind of important to us. So when we were trained, we did lots of lab experiments on microwaves, looking at how they were, what they would do in the lab.
And I've got a question about how space fits into this. Are you trying to say that everything, the entire universe, exists within the 6,400 kilometers of us?
Yeah, on the concave model, between us and the center of the Earth, well, that will be 6,000 kilometers. So everything it's inside the Earth. The celestial sphere, I suppose it's about 2,500 kilometers on diameter. So by bending light, we see a concave sky surrounding us, but it's really a small sky in the center.
How do you reconcile the differences between the radar ranging we get then, when it comes to, say, something that's easy to range like the moon?
Well, I didn't understand your question.
Okay, we have used radar to measure the distance between Earth and the moon. That's a lot further than 6,000 kilometers.
Yeah, but when you say we did, actually, what do you mean? Have you done it? Because I was looking for an experiment which shows that a laser or something, a wave is going to the moon, doing 1 second and 1 second way back. So
Actually, it's
the
about
only video I've seen is the Mythbusters. That it's like a joke. I didn't see any scientific experiment proving the distance by the moon by throwing a wave.
I've personally measured an object about 30,500 miles away. Personally, and I've done it multiple times.
Secondly, in ham radio, there's a thing called EME, or Earth, Moon, Earth, where a radio signal is bounced off of the moon and comes back to Earth. Now, radio waves travel at the speed of light, and for some strange reason, the delay fits exactly the speed of light out to what we've measured the moon to be and back to Earth.
Yeah. The round trip delay is 10 microseconds for every 1,500 meters.
So, do you got any link or something to that experiment? I mean, anybody did record it on video and upload it on YouTube? I haven't seen it.
Go talk to any amateur radio operator that is local to you, and they can tell you that this actually does happen, and many of them have done it.
We do have people who
I'll bet you can find some that'll actually let you have done it.
Yeah, many radio amateur clubs, if you go and ask, they would probably try and help you do it because it's the sort of thing they like to do.
Here you go. there's a link in the side that will take you to
Um,
the British, the Radio Society of Great Britain.
yeah. Aussie
And they
baller,
talk-
Peter Harrington, who is a regular member of this panel, has done an EME. He just posted it in the side chat. Unfortunately, we can't get him in here because Jose's not here to let him in.
Oh, I thought it's because he was a git.
Oh, well, there is that too, but
Cool. I am going to run away and drop off, but it was really nice to meet you, and yeah, take care, dude, and catch everybody else later.
Later, Gator. Okay, I just did a quick and dirty calculation, and I may have my decimals wrong here, so I'm just going to say that right up front. But it appears that using, whoops, hang on, I'm getting blocked here on the input. I'm posting into the side chat here the figure that I got for an Earth, Moon, Earth bounce. And if my calculations are correct, again, I may have gotten the decimal wrong, we're looking at 2.56444 seconds.
well, of course, it depends exactly where between perigee and apogee you are, but it's about 2.5 seconds, yes.
Yeah, that's just an average. I was using average figures for moon distance.
Yeah, that would be good. Like I said,
So-
it's really
so-
easy. It's 10 microseconds per 1,500 meters.
Okay, so I got basically what we're saying is, and this shows to be true by experimentation and demonstration done by tens or possibly hundreds of thousands of people all over the planet, showing that the distance from Earth to the moon via speed of light is about 2.5 seconds away. That's a lot further than just, 6,000 kilometers, a lot further.
Okay, but somebody says that a guy who is coming here usually has done the experiment on uploaded on his YouTube channel.
No, it's not uploaded on his YouTube channel, but not everybody records everything they ever do, and some people did stuff before YouTube was even a thing, and before widespread availability of video cameras was a thing.
And as I said, go to your local radio, your amateur radio clubs, because they're all over the world, and ask someone to help you do an Earth, Moon, Earth transmission. And I bet you somebody would help you do it, so then you can do it yourself.
Because I'm sure most clubs will have the equipment available to do it.
Anyway, if I go and they will do it, I will record it and I will upload it on my YouTube channel. So, and any result of any experiment, I will upload it. So, there are a lot of people. They say, the horizon it's climbing with the observer. So I've done an experiment proving that is not the horizon. It's going down as you climbing up. So
well, if we're inside a concave Earth, inside the Earth, then that horizon would continue going up, not just like the flatties say, but it would go up even faster because it's curving up.
No, because on the concave Earth you got the bending light. So with the bending light you got the same visual effect as with the ball Earth.
But you've got bending light in both directions at the same time.
And
in that case, and somehow they're not going to interact. Somehow they're not going to. Somehow it's going to be different, even through the same band of atmosphere.
And this bending it with some process that we don't know and can't measure.
Exactly. So the light is bending upward by some reason that we don't know.
I had to stop you there. You're telling us that there's something we don't understand, which is fine, but it's going to necessarily be contradictory, and we can't measure it ever. It's an illusion.
Yes, we can. I think we can. I think we can measure it.
But I remember that refraction is frequency dependent in the material. So blue light is refracted more than green light. Green light is refracted more than red light, and radio waves are barely refracted at all when it comes to Earth's atmosphere. So yeah, I would really like to hear any sensible prediction of what is going to make all electromagnetic radiation move in ways that we have been unable to measure. Oh, and also how would you explain the ground wave of radios, which is an interesting phenomena in that it manages to make radio waves actually bend round the curve because of the capacitance of the surface of the Earth. That would actually not work at all, because the capacitive coupling of the radio waves acts to reduce their velocity, which causes them to essentially bend round the planet for low frequency transmissions. On a convex Earth, if we were on the inside, this would actually reduce the range of the radio, not increase the range of the radio.
So I don't understand all you're saying and that technical terms, but anyway, I hope that someday it could be measured, because I think that the theodolite experiment combined with a water canal on the side could reveal if the light really it's bending some way or is going straight. And there is a lot of other experiment that can reveal if the surface of the water it's really straight on a flat Earth, or it's bending downward on a convex Earth, or it's bending upward on a concave Earth. There are many now, but there are several experiments that could be done.
Yeah, but like I say, there are the propagation of radio waves, which is electromagnetic spectrum, just like light, pretty much shows that it can't be concave, because the way we know that radio waves work, some transmissions, instead of going further than they ought to, actually would be stopped much quicker. Radar systems, and I say, unless you can show a mechanism why all wave bands would be curved in the same way, in a way that we've never measured and can't see, you can't just say magic.
I've got a question. You're saying that light is bent and curved by some force that we don't know or can't explain, and bends it in a particular way. Should light be bent, say, within 1,000 kilometers of the point that emits it? In 1,000 kilometers, light should bend at least a little bit, right?
Yeah. In 1,000 kilometers, the light should bend double of the curvature of the Earth. So
Okay. All right. Let me drop this bomb in your lap then. Do you know what LIGO is?
light go.
LIGO, LIGO.
Oh yeah, there is one in Arizona. There are two tubes on 90 degrees.
Well, it's Washington and Louisiana, but the arms on that, the light bounces back and forth, back again and back and again several times in those arms, effectively traveling 1,120 kilometers.
Yeah, there are two tubes on a vacuum.
Yeah, and the light beams that they shoot down those arms travel 1,120 kilometers. So why don't those show any curvature?
Right. So supposedly, those two tubes of 5 kilometers long, they are straight, perfectly straight. They are not.
Yes,
they are not following any curvature, but they are just straight.
They are.
So why doesn't the light curve inside them?
Well, that's I really like to visit those installations, but I think they would not allowed any of us.
Oh no, they absolutely allow it. Sasha had a presentation from there.
Anyway,
and also those arms, to be perfectly straight, are over a meter. I think they're getting on nearly for 2 meters above the ground level at the far ends, at one end compared to the other, to compensate for the curvature of the Earth, so that they are indeed straight.
But I want to get back to my original question. Why isn't the light curving or bending in those?
That is a good question.
Well,
1,000.
you mean? Well, the point is, I don't know if the light is bending or not on those tubes, right? So I've seen on Google Earth, where I was watching, one of those laboratories, I think the one of Louisiana, is got a canal, a water canal on just on the side. There is a road on the side of the tube, and just on the side of the road there is a water canal. So there is a very good place to make a measurement by taking the water level on just close to the angle, and take the water level on the end of the 5 kilometers tube. So just seeing how the tube is going, because the tube inside is, I think it's a metal tube, but the exterior it's a concrete tube, like 2 meters or 3 meters on diameter. So just taking the level of the concrete tube, we can get a clue about if it's going straight or if it's following some kind of curvature.
You actually probably wouldn't be able to detect that.
Saying,
wait. You probably wouldn't be able to check that with a water level. With your standalone water level, because the degree of curvature over the distance that LIGO that the physical LIGO is not enough to even get to is barely a fraction of 1 degree of tilt.
And anyway, if the Earth is concave, those tubes, in order to get the light reflected several times, it has to be bending upward, because if you make it straight and the light really it's bending upward, you will not get the experiment.
Exactly, and it works. So how do you explain that? You can't. That's the thing.
But the problem is that I don't know if those tubes are perfectly straight or they are bending upward or downward. I don't know. I wasn't
They
there.
bounce that light hundreds of times up and down this tube. It has to be pretty damn straight.
Yeah, but that's on the case that the light is going straight. But if the light is bending upward, they should be bent, the tubes.
It
But
should
the thing
bend
is, you're-
upward. It should bend upward as it goes out, and then upward again as it comes back, and then upward again as it goes back out, and then upward again as it comes back. It should continue being upward. There's nothing that says it bounces and curves down again back to the original mirror.
Yeah, what you're actually
No.
positing is
They-
that the light would have. What you're actually saying that the light would have to do a U-bend through the damn thing over and over again, not bending up. You would have to bend down, then bend up every time for your statement to be accurate.
So what the reason I'm asking this is because
No,
you're saying that light bends. You know it bends, or that you believe it bends. However you want to represent it. But you have absolutely no evidence showing that it does, and we have evidence showing that it does not, and you refute it by saying no, I don't believe it.
Yeah, but I really don't know if the light is bending up or is going straight or whatever it does. But when you say that,
so then you have nothing.
got an
You have
evidence-
nothing.
an
You have
evidence,
you have no evidence that supports your conjecture or your hypothesis that we live in a concave Earth with a diameter, a radius of less than 7,000 or 6,500 miles or kilometers.
no, I got no evidence, but you also got no
I'm gonna
evidence
stop you
because
I'm gonna stop you
legal
there
experiment-
and say, no, we have plenty of evidence. Just because you handwave dismiss it doesn't invalidate it.
okay, but those experiments like LIGO, it's not on our it's not staying in our hands to check it, right? So there is scientists. They just told us the tubes are straight, so we just have to believe it.
A friend of mine makes his living with lasers, using lasers and making sure that they point exactly where he points them and goes exactly where he tells them to go and does exactly what he tells them to do. He never has to calculate any sort of curvature or bending in those lasers due to some unknown force.
Right.
Actually,
we are not
RT76 in
aware.
the chat. Wait. RT76 in the chat has you pegged to a fault. He says, I make no claims. I have nothing to defend. I know nothing other than everything you say is wrong. But I make claims and know nothing. But I make no claims and know nothing. You're essentially worthless to me at this point. And I'm not trying to be mean, but you're coming in here saying everything is wrong. I know the correct answer. I can't defend it. I have no explanation, but I know that you're wrong because I'm right. And I know that I'm right. And I know that I'm right based on nothing.
And that's why I was pressing this issue.
I didn't claim.
You have no evidence to support any of your conjectures, your hypotheses, or your assertions.
But we are on the same position, because if I recognize it, I don't.
We are not. We have tons of evidence. You have nothing, and you're just trying to dismiss our evidence offhand because in several cases, you just don't know how to make it work, or you can't fathom it because it's not intuitive. That's not the same as ours is invalid.
But what, for example, we were talking about the bending light, and you asking me what evidence do I have. So I said I just have the clue, the result of the German experiment,
who we couldn't verify. You didn't know the name of, and we don't know if his. And since we can't verify, we have no idea whether or not you're telling us the truth.
So the name of the German is Wilhelm Martin, right? I can provide the experiment. The experiment, the guy exists, and you told me that your evidence is LIGO. So LIGO, it's not an experiment that we can check. So if I go to LIGO, they won't allow me to do some measurements on their facilities. So it's
wait,
something that
wait. What is your level of education?
0.
They're not going to put somebody who knows nothing in charge of a multi-million-dollar machine. That's like showing up to a construction site and saying, I'm going to operate the crane when you've never even seen one before.
Exactly.
That's not.
So
Yeah, exactly.
So
What do you mean exactly? Of course, exactly. You want them to let you run this machinery when you don't even know how any of it works?
no, I didn't say run the machinery. Just make some measurements on that facilities or just observing. So they won't allow me, they won't allow you, they won't allow anyone on this chat. So that is not evidence, because that is something that we cannot check.
They're trying to make sure that someone doesn't break million-dollar machinery, and you're saying that that means it's invalid. By that measure, the majority of things on Earth don't work, including road graders.
Well, I've got a better question. Have you ever been to China?
No.
Then how do you know it's real? Or do you not believe that China's real?
Well, I think that China is real because I've seen Chinese on Spain.
Yeah, and I've seen pictures of the Earth from outer space.
I seen too, but I don't believe it.
And I don't believe in China.
Why?
Yeah.
See, this is what we've come down to. We've now reduced it to its base. What you have to argue from is ignorance and incredulity. And I hate it when people come in with that particular set of argumentation.
Testify, brother.
So anyway, do you have any experiment that prove that the light is going straight on 1 kilometer?
You're not going to reverse the burden on me. I'm arguing from the consensus position. You're going to have to actually provide some evidence instead of sitting here going, do you have? You're not as clever as First Chemo, and you're damn sure not as charismatic. Now, please, for the love of God, put up or shut up.
Put up? What do you mean?
Put it on the table. Lay it out there. Show us something. Don't sit here and demand from us when we're arguing from the position of evidence.
Basically, he
All
says,
right.
give us evidence or stop talking because you've got nothing.
No, I'm just making questions because there is experiment that could be done by normal people, not by multi-millionaire LIGO facilities.
You are relying on a false notion of what science means. Scientific experiments, they do not mean that every single person on Earth should be able to do it. Children in Africa are not able to do the Cavendish experiment, and they are not able to do the laser experiments. Does that mean that those experiments are invalid? Do we need children in Africa with $0 who are starving and actually dying currently? Do we need them to be able to do the experiments as well for the experiment to be scientific? No.
No, but even if the children in Africa are not able to do the Cavendish experiment because of the economic budget, right? But if I go with my device, with my Cavendish device on Africa, I can show a kid from Africa that the attraction between masses is not existent, right? Or
You can misperform an experiment, sure.
Right.
You've already proven that you can't get it to work, but there's so much evidence that it does work. It's been repeated so many times. Your inability to perform it, which I think is going to be purposeful, does not invalidate the science behind it.
Yeah, but there is a very cheap experiment that it can be performed and can reveal that the light is going straight or it's bending some way.
And you would have to
Not-
prove that it's performing multiple U-bends.
And I've got a question for IGOT. If you did have access to LIGO, exactly what experiments would you perform? That question, by the way, is from the YouTube chat. Genesian, I believe is how you would pronounce it.
Yeah,
what would you do at LIGO?
This is a very good question, because on the LIGO they got the tubes which they put vacuum on it. They suck all the air. So first of all, I will do a water canal just on the side of the tube to see the difference between the water level and the tube. So if the official version is correct, the water should going down, right? If the tubes are made on the horizontal where the angle is, the water canal, which is on the side of the tube, should going down on 5 kilometers. I don't know the curvature, how much could be, and the tube.
It's a little over 2 meters, and they already have that. And they already have that basically done in the offset of the concrete underneath the tube. Towards the end, you get a decline. It's already accounted for. And if you're going to do that, they're sure as hell not going to let you into LIGO, because you're going to include thousands and thousands of gallons of water next to incredibly sensitive electronic equipment.
No, the water level it could make by
You said a canal. Not going to be able to dig a canal in the damn thing. So no wonder they're not going to let you in. Can you provide us something within reason that you could do at a LIGO?
I believe he's making the assertion that there's a canal nearby already, pre-existing.
Yeah, there is a canal. I think it's the Louisiana one. There is an outside canal of the.
Oh, are you talking about the canal in Livingston Parish?
But anyway, the level of the water, it could be checked not by a canal, but by hose, transparent hose. I think it's called, a level hose.
I'm actually going to hit Google Earth real quick and locate the LIGO in Louisiana.
It's in Livingston Parish.
Thank you, sir.
I get the feeling you're from around that way.
If the curvature is 2 meters in 5 kilometers, so and the concrete tube is going straight, we should see a difference in level from the canal to the concrete tube of 2 meters, right? Because
I'm sorry, I wasn't paying attention to you. What did you say?
We could check the level of the tube on the end and the level of the water of the canal. If the canal it's stationary, it's not flowing the water, so we should get the same level.
It does flow, just slowly. It's a canal. It's connected to a bayou. It's not without current. It's just a very low current.
Right, but could be a day when you can stop it, or just block it for a moment, just to make the measurement. So
I also have no idea where you're going with this experiment.
So if you're gonna try to you're gonna try to suspend a hose with thousands of gallons of water, because with hundreds of gallons of water if you're gonna use a hose from this thing, that's one thing. I don't know where you're trying to go with this or what utility you think you're going to get out of this, because the canal itself is not right next to it. It's a bit off, and I'm not sure what you think.
Yeah,
you're gonna try to do.
there is no canal nearby. I'm looking at an aerial shot of LIGO as we speak. And
Yeah,
I'm going to measure to the nearest body of water that I can find. And hang on. Here we go. Yeah, there's nothing that flows next to either of the LIGO tunnels. Yeah, I don't know if anybody can screen share this, but it's definitely worth looking at.
Yeah, give me a second. I'll see if I can get that figured out on how to share that.
It would be better for somebody other than myself to do it, because you guys can screen share into me, and everybody out there gets to see what you're sharing. If I share it, you get to see it, and YouTube doesn't.
Okay, he's talking about Coley Creek, which is not straight, and which is not straight by any measure. So I don't know what he's after with this.
Yeah, there'd be no way to measure off that Colliel Creek.
Okay, so I'm already upset with you because you lied about there being a canal right next to it. So what do you have to say for yourself?
Livingston. I'm looking at a LIGO on Livingston, but it's not this one. Which is the other one?
It's, I believe, Hanford and Washington State.
Understood.
As far as I can tell, here in Hanford, there's not one either.
Yep, nothing there either. That area is a desert.
Yeah,
Yeah, I didn't know if maybe there was a creek nearby.
I'm looking at on the forest.
Yep, it's not far from the Columbia River, but it's not close enough to take a site measurement.
Yeah, I'm actually thinking they wouldn't build really close to a river of some kind, because they actually try to isolate as much as they can from environmental effects.
No, it's.
For example,
this is not a river.
Cars passing by and so on.
I'm with the mobile phone, so I don't know if I can share the screen.
Oh, you can't
I
share on
think
the
I
mobile.
can't. I
Not
think
on
I
the mobile.
can.
No.
But anyway, I'm looking at Lego Livingstone, right? And if you put the north upward, you got one arm to down and one arm going to the left. So on the left arm, just above it, you got a canal, and it's going from the building, where is the facility, just to the right, to the left, just to the end.
Where are you
It's the
seeing
same
this?
canal, and it's got water on it.
What are you talking about? You've got Hornsby
You've
Creek,
seen
and
it.
you've got Colyell, and you've got Colyell Creek, but they are creeks. They are subject to topography, and they are not canals.
And the LIGO in Washington State is approximately
Okay.
11 kilometers from the nearest sizable body of water.
There is, if we got a canal just on the side of the concrete tube of Lego,
Which we don't
we
have.
should observe.
They're
Yeah,
not
but
going to let you
in
build it.
theory,
They're not going to let you build a canal in LIGO. So pick something else.
all right. But just let's say it's already built it, right? So the
No,
theory
let's say
is
let's say in reality. Well, how are you going to test it?
that's what I'm telling you. If the theory is that
No.
you say that
No. What would you do if you could go in and try to validate it? Don't make up something that they're not going to let you do. Please tell us something. Please tell us something that you would go to do as an experiment there within the bounds of reasons.
yeah, but listen, please. You claim that those tubes are perfectly straight, right?
Yes, I want
be.
you to try to validate that with something that you can actually do. Now, please do it.
Yeah, what I'm saying is that you don't know if those tubes are actually straight or not, because we have to believe what those people tell us.
I have to believe what you're telling me, and you know what they have? Years of experience and evidence. What you have is fuck all.
No, I don't. I don't want you believe in what I say, because I just have question.
Then why are
I'm
you
not
arguing?
claiming anything.
Why are you arguing with me that I should believe things that you? You're arguing that I should believe things that you say, whether you want to admit that or not, and you're not giving me a reason to believe it, other than everyone's lying to you, and then
No,
ignorance
I'm
and
not.
incredulity.
No, I'm not arguing, and you don't have to believe anything. I'm just making questions that if you can
Well, you're not
pick it up.
accepting answers, and you're positing bullshit in its place.
But let me explain my point of view.
Go ahead.
If we can allow, if we are allowed to those facilities, and by some reason there is a canal,
You are allowed in those facilities. You are allowed in those facilities. You can walk them. You can go. You can go to their science centers. You're allowed in the facilities. You're just not. You're not allowed to play with the equipment or in certain rooms.
All right, but let me speak. Why don't you speak over me?
Because you keep saying things that are patently false. Say right things, and I won't have to interrupt you to tell you why you're stupid.
but you're not the judge to say if I'm telling right or wrong. Just let me explain
Except that we know people who have been there, been to the facilities, and toured them.
And you're telling us that we're wrong.
Tours.
And you're telling us that
No,
we're
I'm not.
wrong.
No, I'm not.
I've been unfair to you. I'll let you finish. Go.
All right. So if on the side there is a canal, we can check the level of the water with the topper side of the tube. right? So let's say there is a 2 meters difference between the water and the tube, right? So if we go with the theodolite on the end of the tube on the 5 kilometers, and we check again the level of the water and the upper side of the tube, we should see a 4 meters difference, right? Because the water should going down and the
You don't
tube.
There'll
need
be a hill
you,
on top of the tube in the middle.
you don't need water for a theodolite function or theodolite function.
You would just
I
do
need
the, you
to,
just do the
I
measurement
need,
from
I
you would
need
just
the,
do the measurement
if,
you would do the measurement
if,
from the road next to it, and then you would do a measurement from on top of the tube. You wouldn't need to do this canal thing that you've already admitted there is no canal. Stop trying to build a
I,
goddamn canal.
I need the theodolite to check the difference between the level of the water to the level of the tube. How can you check it without the theodolite?
You set each theodolite level to gravity at its point. You set it plumb, and then you measure the reciprocal angles. You don't have to do that. You don't have to do that at water. You don't even know how a damn theodolite. You don't even know what. You don't even know how geodetic surveying works, and you're gonna lecture us on it.
It's obvious you don't understand me, and maybe it's because my lousy English. Maybe.
No, it's your lousy logic. We understand your English perfectly. You're trying to say that you need water for a theodolite to work, but it doesn't. Mathematics does not require water to work.
No.
Nor do optics.
No. Those guys are claiming that those tubes are going straight, perfectly straight. So you believe it. You say, so if those scientists tell us that the tubes are going straight, why should they lie to us? So what I'm saying is, I don't trust in anybody.
Incredulity,
I don't trust them.
ignorance. Paranoia, incredulity, and ignorance. That is all you were saying to me. Can you please provide me some positive evidence instead of just saying you can't believe anybody, please?
So if you wait for me to provide evidence, I don't have any evidence. I just have
Thank you.
questions
Then get out.
that you can.
Get out. You don't have evidence. Get out. You're not worth talking to. You don't care about them. You don't care about the answers. You have questions. You don't give a fuck about the answers. You want to go ahead and put your answers in there and say, you don't have to believe me, but this is correct. Don't ask me about it. Don't tell me wrong. Don't tell me right things. Don't tell me anything. Don't believe me, but accept it. I'm not accepting anything you have to say. Get out.
Semantic toy soldier. I don't have answer. I got questions.
You don't accept answers, so you don't give a fuck about, and so your questions are worthless.
Why do you want to ask questions if you're not willing to listen to the answers and give them consideration?
I give consideration to any answer.
But you tell us we're wrong. You tell us that maybe we live on a flat Earth. Maybe we live on a concave Earth, but we don't live on a ball. Well, you say that observations show the horizon not just curving up to eye level, but going up higher than eye level. Well, that excludes a flat Earth because it can't go above eye level on a flat Earth. So now you don't believe in a flat Earth.
Hang on, excludes a concave Earth.
Hang on, I'm sinking the fangs in here. So now you've shown that you do not believe in a flat Earth. You have admitted you don't believe in a convex oblate spheroid Earth, a round ball Earth. So that leaves one thing. You believe in a concave Earth, which means that the entire observable universe must be within 6,500 kilometers of ground level. You have not demonstrated that, and you say that it is observed as being bigger because light bends. Well, you've been given evidence showing that light does not bend the way you say it does. Well, we can't see it. We can't measure it. We don't know how it works. Okay, what experiments would you perform at LIGO showing that it does not work the way you say it does to show that it does work the way you say it does? What experiments would you perform?
Okay, so I would perform the fishing line experiment.
What is that?
Well, the fishing line experiment, it's give us a perfect straight line, which will be a fishing line by neutral density, submerged and stretched inside of a canal, of a liquid with same density.
You're not going to be able to build a goddamn canal next to LIGO. Please pick something that is an actual experiment that can be done.
Yeah, the fishing line
No, to be fair,
experiment.
that can be done anywhere.
The fishing line experiment, you can do it whatever you want on any place. You don't need any LIGO facilities to do it.
Just need flat, still water.
Now, how does that relate to LIGO?
Well, the LIGO facilities, it's supposed that provide a perfect straight 5 kilometers tube. So what I'm saying is that we don't know. At least me, I don't know if those tubes are perfectly straight or are bending upward.
Do you have reason to?
Bending downward?
Do you have any good reason to believe they are not, as stated, straight?
Especially considering what their function is. They want a straight laser to shoot through them.
Do you have any good reason to believe they're not, as we are told they are?
Yeah,
I mean, if you
because
have,
yeah, but what my reason is that if the Earth is not like they say it is, and it's probably concave, so those tubes must be following a tiny curvature upward.
but then the light bouncing back and forth would show that there was a curvature in the tube, and it would not go for 1,120 kilometers.
No, unpaced shields. That you're saying because you don't know how the bending light is working. If you got,
do you know?
Yeah, as you're talking, I'm knowing better than you.
Okay, explain better than me.
All right. So, if the light is bending upward, to have an ingoing laser, you don't have to bend the tube several times. You just bending once. So you just pointing the laser a little bit downward, and the mirror on 5 kilometers a little bit downward, and you got the path. So if the light is
except it reflects many times. If it were the case that it were bending upward, that would mean that it would hit the top of the tube and cease to transmit after very few attempts.
No, because even if it's bending several times, you just pointing the laser and the mirror a little bit downward, and you got the going and coming way. It's the same. We'll never hit.
Except now you're forgetting angle of incidence, and that's going to fuck with you again. Unless you're saying that every time that laser is bouncing, which is a continuous beam, not a single pulse beam, that somehow this mirror is constantly redirecting hundreds of bounces simultaneously. It's just not going to work. Think what you're saying. Think about what you're saying before you let bullshit fall out of your mouth.
The laser in each one of those arms, the laser bounces back and forth approximately 240 times.
It doesn't matter.
Yeah, I'm pretty sure you're a troll. Why are you even here if you don't care about this?
No, I'm not a troll. So,
I think you live under a bridge. I really do. I don't even. It's not even that you're homeless. I think you're a fucking troll. I think you live under a bridge.
if the light is going straight, the laser will be pointing exactly the mirror. But if the light is going, is bending upward, the only difference you got is that the laser will pointing a little bit downward, and the mirror will pointing a little bit downward. But the way to one way and coming back is the same. It's the same bending light.
No, because
Okay.
you cannot do that. So you're forgetting about angle of incidence and the fact that the beam is a continuous beam. You see what you're describing is quite literally a physical impossibility.
What force would cause that light to bend? What would cause that to happen? And I'm not going to accept I don't know as an answer. If you're going to assert that this is what's happening and you're going to just wave away all of science because of this, I want a reason.
Okay, but if I'm asking, what is do we know the cause of the gravity? You told me, why should we know it? Why? It's working. We don't have to know the cause. So now, are you asking me?
We're asking you a mechanic. We're asking you a mechanic. We're not asking you. We're not asking you where light came from. We're asking you what is the mechanism by which it bends.
And why?
We have evidence that it works the way we do, and that's what we're based off of. You're saying just because, and then saying, "Oh, I don't have to explain just because," even though we have evidence in the contrary. You can't go up against evidence and say just because.
I'm just a guy who lives under the bridge, so I don't made any experiment like legal one to tell you which is the cause. I just have theories. I can tell you.
No. A theory.
You have conjecture.
You have conjectures. You have assertions. You don't even have a hypothesis yet.
Yep. To clarify the position where you are at in comparison to our gravity, we cannot necessarily explain exactly how gravity works, even though it's been a long time. But we have observations showing that it does what we say it does. Now, you do not have the explanation, but it goes worse for you because you do not even have the observations that what you're claiming is true. So it's not comparable.
So, for example, the particles that have mass, like protons, they are accelerated downward by a force. We call it gravity, right? So it could be that the particles that don't have mass, like photons, they are experimenting a different effect. Instead of being accelerated downward, they are accelerated upward. So that could be a explanation of why the light is bending upward.
Except that we have an experiment from 1919 that shows it would be the opposite. Seeing stars around a solar eclipse.
Right, but that experiment is not doing on the Earth gravitational field. It's doing
according to you, it's all within the Earth. So what would it matter?
It's matter because
are you saying space does exist and we looked at it correctly? Thank you for proving that the Earth's not concave. See you tomorrow.
Yeah. you also have about 120 years of practical use of radio systems that also disprove any notion that we might be living on the inside of a sphere.
I've got I've got a couple of questions I'd like to ask him, just kind of calmly, coolly,
Yeah.
collectively, because I would like to point something out here real quick. I got. Do you believe that light can be bent by gravity?
So it's one of the reason that I think could be the cause of the
Okay.
bending.
Do you believe that it can? I mean, at this point in time, would you say, okay, I can accept that gravity bends light?
Yeah, could be one of the possible reason that.
No. Do you find it plausible? Do you think it's reasonable that gravity bends light?
Yeah.
Okay, good. We're that's the first step. Do you agree then also that photons have no mass?
Yeah.
Okay, photons have no mass. Gravity affects the directions of photons. How do they interact? Through a curvature of time-space. In curved time-space, parallel lines can cross. Straight lines do bend.
But the fact is, I don't believe in the curvature of space-time.
Well, you know what? You just said you did because you believe that gravity affects a photon and a photon has no mass. How does gravity affect a photon then? The only mechanism by which it can do that is through a curvature of time-space.
No, that's what you're saying, but it's not have to be like this.
It's what the evidence says.
Then what is it? If it's not gravity curving time-space, or excuse me, if it's not a manifestation of a curvature of time-space, then what is it?
What is it? What? We don't have any proof of bending space-time, which is the experiment that proved.
Yeah, actually, we do. We have proof of the curvature of time-space every second of every day. You have a proof in your hand right now, your phone. It has a GPS system. GPS depends on relativity. Relativity is an explainer of the curvature of time-space.
Look at GPS satellites. Look at cesium clocks traveling overseas in planes. It's there.
So therefore, we have a curvature of time-space that has been demonstrated to you, whether you like it or not, and you have no mechanism that you can give us by which light would bend in the way that you say it bends. You don't believe in a flat Earth because you said the horizon continues bending upward above eye level. You don't believe in a globe Earth, so that means only a concave model. You can't give us any kind of explanation by which light would bend in the way you're claiming it bends. The only option left is the oblate spheroid, this lovely spinning globe we call Earth.
It's not lovely. It's a lie. The oblate.
The ugly globe lie.
What do you mean
So-
the demonic spinning ball?
Demonic spinning ball, right? So anyway, I would like to check the bending of space-time by the GPS, but I don't know how to do it. Just because my phone has GPS means that the space and time is bending.
You see, this is why I know that you don't understand our model. You don't get that time dilation.
Okay, here's
necessary in GPS satellite communications.
Here's why I brought up the GPS systems, because those satellites are far enough away and they're moving so fast that we have to use relativity to account for time dilation for the time codes that those satellites are constantly broadcasting out. Because your phone GPS system works by listening for time codes sent out by multiple satellites and then triangulating those time codes to find out your location.
34 microseconds per day error.
And that relativity, because of the accelerated movement of those satellites, that's why I brought up GPS.
All right, unpaid shields, but how can I check this information?
You can start by reading a book.
And then signing up at a decent school.
Can you? You can paint GPS satellites, can't you?
No, by reading a book, I cannot check anything. I cannot check the delay on the satellites.
Man, where's Dross when you need him? I want to know if you can ping a GPS satellite to determine its location.
I don't believe it's
the
possible.
No,
The
you
actual
don't have
delay
receivers.
is measurable.
And what I meant by read a book was you need to start learning mathematics. You need to start learning more about science because you have some fundamental misunderstandings about how the universe and the world works.
But unpaid shields. What about easy experiments, which can do with everybody, not just reading
If you don't understand the fundamentals of science, and if you don't understand fundamental mathematics, then you can't understand basic experiments to the fullest degree necessary.
But look, to perform a easy experiment that can reveal if the surface of the water it's convex, flat, or concave, I don't need to know mathematics.
Actually, you do, because you need to understand the rate of curvature, or rather, you need to understand that was the amount of curvature that you would have over a certain amount of time or distance. Like there's a lot to it. Just laying a fishing line down on a canal does not tell you flat level. It doesn't tell you flat in any way, shape, or form.
Well, in actuality, I'd like to explain this experiment, but it's still flawed as hell. If you pull the string, let's say a mile, and you pull it taut and it's neutrally buoyant, it might pull below the surface and indicate the shape of the Earth. The only problem is that the line's going to change its buoyancy as you pull it tighter. It's going to have all sorts of flaws that it makes it impractical. But it's a neat idea of a test, but everybody who's tried it actually failed. The line just snaps whenever they try and get it tight enough to show anything useful.
I was about to say the tensile strength wouldn't put up with you pulling that much.
And you don't have to support it above the surface. You actually support it in the water, so it's neutral buoyancy.
And as the line stretched, its delta density would change, thus causing it to fluctuate.
Yes. But the easiest test I've seen that you can validate GPS with is you can build a GPS with a software programmable radio receiver. And if you understand enough about math, you could then verify it yourself.
You'll have
all the knobs of it. Yeah, you'll have all the knobs available to you. You'll see the actual time delay. You'll find out the almanac message, and you have to understand the almanac message to determine where the satellites are. And then by that, you know that there's nobody in the middle of this, no government agency hiding information from you, fabricating information. And therefore, the satellites are moving very fast and at like 12,000 miles away. It self-proves once you understand it and build your own system. And it's absolutely 100% unfabricatable, unfalsified, unfakeable.
And the thing is, to understand these things, you have to have a foundation in science and mathematics, at least the basic concepts, before you take that first big step.
Yeah.
So unpaid shields, how it helps your foundation of mathematics when you say that the fishing line, when you stretch it up, it's changing density. How do you know?
Well,
have you ever pulled fishing line taut? We just talked to you about that.
Okay, when you pull a fishing line tight, does that fishing line stretch?
Well, I don't know.
Does it stretch?
See, this is why you need a better foundation. You don't even know if fishing line stretches if you pull it tight.
Okay, how about this? If I'm holding a piece of fishing line and one end of it, you're holding the other end, and it is exactly 10 meters long, and you step back 1 centimeter, still holding on to it, is that line going to stretch?
So what you mean that the diameter of the fishing line is going smaller?
Eventually, yeah, or yes.
Which will change the density of said fishing line, meaning it will no longer be neutral buoyancy.
No. If the
Really?
line is stretching, doesn't mean that it's changing the density, because the volume still the same.
He's talking about it as a whole versus in the segment that's stretched.
Well, it actually
But-
will be. Let's see.
But that's it's a theory that you got, that if you pull a fishing line, it's changing the density, but it's not proven.
All right.
You have to prove it first.
Okay, I will prove it. All right. How long is a 10-meter piece of fishing line? How long is it?
10 meters.
Exactly. Now, if it is 1/100th of a meter, or excuse me, 1/100th of a centimeter across, how wide is it?
1 centimeter.
1/100th of a centimeter across.
All
How
right.
wide is it?
100.
Exactly. Now hang on. Now, if you pull that line and it stretches to 10.01 meters, okay? You follow me so far?
No.
You stretch it to 10.01 meters. That's 10 meters plus 1 centimeter.
Okay.
The amount of volume that takes up is going to change.
No.
Why?
Because if you got a smaller diameter, you got 1 centimeter more length. So the volume still stay the same.
And what material would stretch evenly, perfectly evenly across a 10-meter length? There's going to be spots that do not stretch the same. That is a change in density.
Well, what you're saying, it's not a fact. It's just what you think. Because
you don't have any idea what a fact is. You've already said you don't have any sort of education or any sort of background in material science. So
Exactly.
why are you speaking as though you have expertise in that fact, in that field?
But so unpaid shields is not an expert on that field. So if he's an engineering of whatever, but he doesn't make.
You're telling him he's wrong. You're telling him he's wrong in spite of evidence to that fact, point blank, with no background, no education, no backing, just your declaration. You're going to have to bring up that's not semantics. God bless America.
No. He's addressing semantic. He's addressing you. He wasn't saying it's semantics. He was addressing you.
I thought he said that's semantics.
No. He was addressing you.
Yeah, semantic toy soldier. I didn't say you're wrong. I didn't say unpaid shields is wrong. I just said
you said no. That's not how that works. And then you told him that it stretches uniform.
No, you're not listening. You're not listening. I just told that he doesn't know. It's his theory, all right, against the reality. The reality, we cannot know it until we do some kind of experiment. So if we put, let's say, 1 kilometer of a fishing line inside the water, right?
But you're already getting away from the material because you don't understand whether or not the material will break. And you don't understand how the material breaks.
Why are you talking over me?
I'm talking over you because you're trying to get around the fact that you're wrong on a base level. You cannot go to the full scale if you don't understand any part of your component. Now understand your fucking components or stop talking.
Semantic, please calm down.
I was proposing an experiment, a fishing line experiment.
You were proposing something on the basis of things you do not understand. It's already been explained to you that tensile, when it comes down to it, you'll have an issue of uneven tearing, tensile strength issue. You'll have sag issue. There's a number of other things in the way, but you're trying to jump straight to the experiment without acknowledging any of the possible faults. You're just going to jump straight into it. You're just about to jump into it.
Do you know how to listen, or just?
I know exactly how to listen, but you're not saying anything worthwhile, so I feel like it's a good thing to cut you off ahead of time.
I was proposing an experiment, and the unpaid shield says that it doesn't working. The fishing line experiment doesn't working because when you pull the string, the fishing line is stretching and it's changing the density, and that is not a fact. That is a thought. That is a theory. We have no experiment that prove it.
So you want an experiment for your experiment, so you're just going to go on with your experiment? That's not that's intellectually dishonest to the highest degree.
Yeah, because if I propose an experiment, you debunk it with a theory, just saying no, this experiment doesn't work
you with material science.
Because if you pull it tight, it's gonna stretch and it's gonna change the density. But this is not.
That's what I was saying. That's what I said. It would change the density.
But this is not a something that is proven. It's your opinion.
There will be localized changes in density.
I think it's not gonna change and even if it's changing the density should go in low, is not going high, right?
I didn't say it would go low or high. I just said it would simply change. That's all I said.
But if you know that when you pull tight a fishing line, if you know that it's changing density, you should know it's going low or it's going high. If you don't know, it's because you don't know if it's doing or not.
It's not material to what I was getting at. All I was saying is that it would change density, therefore no longer be neutrally buoyant.
But how do you know? How do you know if you don't even know if it's going low or high? How do you know?
What is neutral buoyancy?
It's just your opinion.
What is neutral buoyancy? Hang on, Semantic. Let me field this one. What is neutral buoyancy? Do you know?
Yeah.
Okay, could you please then verify what is neutral buoyancy?
Neutral buoyancy is when the density of the submerged object is the same as the fluid.
Excellent. Okay. When that neutral buoyancy is no longer neutral, what direction does it go?
Well, it depends. If the
exactly. Exactly. I did not say that it increased. I did not say that it decreased, because that depends on the material. If it increases, it will go down. If it decreases, it would go up. I did not make a statement either way. I just simply said the density would change.
All right. So there is materials where if you put more pressure, right, they are compressed like air. But there are other materials, if you compress it, they're not changing volume, like water. So a fishing line, if you state that it's going to change the density, you should know if it's going higher or lower. So if you don't know, it's because you don't know.
It is not material to my argument. All I was saying is it would no longer be neutrally buoyant. It doesn't matter if it's positive, does not matter if it's negative. It only shows that it is no longer at a zero buoyancy state. That's all I said.
But how do you know?
That is all I said.
As a side note, also, there's no such thing as being neutrally buoyant in water, because the water varies in both temperature and and materials. Because of temperature and because of salinity and so forth. You're not going to find a body of water that's uniform like that. That'd be perfectly neutrally buoyant across the whole length.
Okay, now can I go ahead and explain to you how that density would change?
Go ahead.
Okay. When you stretch that line, let's say we got a 10 meter line and we stretch it by 1 centimeter. Okay, where is that 1 centimeter coming from?
From the line.
Okay. What happens to cause it to get larger or to get longer?
Because the diameter is going smaller.
Not necessarily.
No, and where it's come from?
It could come from a shift of the molecular structure, something elastic. Now, typically, I will agree with you. Typically, that happens by causing a deformation of the diameter becoming smaller. Okay.
Okay, so
now, if the molecules in that object, if the matter that makes up that object is being pulled out to either side, that means that matter is no longer there at that point. Right?
No, I don't get you.
Okay, then I wash my hands of this then. I've explained as best I can.
But you have to remember, he knows better than you.
I mean, my motto in life has generally been engage ignorance, shun those who revel in it. I have engaged, I've done my best to clarify things. If you're going to revel in it, I'm done.
Actually got pointed out in the chat as well. Jaren was actually going to try the fishing line example. And then when all the math got done on it, they found out they actually couldn't do it because the materials wouldn't put up with the stress. It would shear, it would stretch, it could potentially break, and the material that would do the least of that was going to wind up costing them thousands and thousands of dollars and still not get them a conclusive result.
All right, guys. So you say that before even started, theoretically, that experiment of fishing line, even if it's a particular kind of fishing line, it doesn't work. That's how you're going to try to tell?
I was explaining
a little bit. I was explaining a little bit of the background to somebody who in the chat made mention of something in the past. And you're more than welcome to go and research it yourself because it's well documented that Jaren couldn't find a way to make that experiment feasible or have it even remotely come up to an example of flat Earth. And that's one of the leaders of FE Corps who couldn't find a way to make that work.
Okay, but let's say I find a way to check if the fishing line or whatever the line is going to change the density.
Hypothetically, you can't do that.
Let's say if I put 1 kilometer line on a roll on some wheel or some way and going tension it, right? And observing the volume of the liquid. If the volume is changing when you stretch the line, well, you know it's going high or it's going low. But if you stretch the line below the water and the volume of the water doesn't change, that means that the line it's maintained the density. So in that case, you can proceed and you can do the experiment with that line. If you previously just check it that it's not changing the
No, it wouldn't.
the
No, it
density.
wouldn't. No, it wouldn't.
But how do you know?
I just know.
you're God?
No, I have my reasons. I can't explain them to you, and there's nothing that I can give you for supporting evidence, but I know for a fact that you're wrong.
Okay, but
Oh,
let's say
that's cheeky.
by some miracle or something, I got
I'm not willing to suspend my disbelief for you, considering that you haven't provided anything of substance.
but let's say I got a.
Let's not say. Let's bound something in reality.
But let's say I got a fishing line that is not changing density. In
You
that
can't.
case,
No, let's use reality. I'm sick of you having sit over here trying to give us fantasy. Please operate with me something in reality. You're caught up
So-
on this fishing line in a canal. Please use some, and it all comes back to LIGO. Please tell me something you would use to experiment with at LIGO that you don't have to go out of your fucking way to invent some miracle substance or dig a canal next to in order to get it to work. Please give me an experiment that can be done in reality without me having to suspend my disbelief and grant you magical powers. Please.
in case of I find a fishing line that is not changing density when you stretch
I'm
it.
not going to give you magical powers. Please pick something that can be done in reality.
But I know an experiment that can prove if the
Please
fishing
give
line.
me something that is not magic.
No, it's not magic.
It is magic.
got
It is magic that it is magic. Please give me something that's not magic.
No, it's
I know
not
you want to
magic.
stick here because I know you want to stick here because you think you have a gotcha, but unfortunately you cannot Anthony Riley your way out of this one by saying it's not a force, it's not a force, it's not a force, because we're good at telling him that he's wrong, and I'm not willing to let you get away with magic either. Now, please give me something that's not magic.
Right. So I got an experiment that can prove if the fishing line is changing the density.
You actually don't, because it's already well-established material science that anything stretched, that material like that stretched, is going to have deformities, especially as you increase it, especially as you increase the weight of the substance and stretch it
Localized.
over a longer distance.
Localized deformities.
Yes, that's well established.
Oh, okay. So let's say I'm doing the experiment in 1 kilometer.
I'm not going to give you this goddamn experiment. Can you please move on to something real?
Right. I got a question, guys.
Yeah, I know you do, but unfortunately, you don't care about the answer.
Somebody say that if we drop something, the trajectory of the dropping object is going to the center of the Earth.
I want to hear
And
about
I
LIGO.
Yeah, you've managed to
No,
dance
it's
away
not.
from LIGO.
No, it's not about LIGO. It's about the.
I know, but you've never managed to come back to LIGO and give us something in reality. We'd like to hold your feet to the fire a little bit, please. Can you give us something in reality to test LIGO?
Yeah, I was just told you the fishing line experiment.
Please give us something in reality.
But this is reality. You can do it. The fishing
No,
line
you're inventing
experiment.
magic. You're inventing a magical
LIGO
substance.
is not under. LIGO has to do with light, and it is not underwater. Your fishing line has nothing to do with light, and it is in water.
Your fishing line experiment, why, if it's so simple, why haven't we done it? Meaning, why haven't we, the flat Earth community / humanity, done it?
The fishing line is it's relative simple.
Say fishing line again. I dare you. I double dare you. Say it one more goddamn time.
Have you done it? And why haven't you done it then?
Because it's not so simple. So in terms of LIGO, when it's multi-millionaire devices, it's simple. But for something who live below a bridge like me, it's not simple.
Okay, so you expect people to invest their time and effort to try and prove this to you, that when it's not a question. This is not a real question. This is a question in your community. It really kind of is on your community to actually test it.
Yeah, it's the same reason why Jared gave up on it, because it wasn't feasible, affordable, or possible.
Interesting.
Who's Jaren are you talking about?
Jaren
It's a flat earther.
Yeah, major flat
Jarenism.
earther.
So there was a Australian guy who tried to do the fishing line experiment. It's not Jeranism.
Well, Jeranism couldn't get it to work because Jeranism couldn't get it to work either. Whenever anybody went through the math with him, including some engineers and some structural scientists, some material scientists, and everything else, it had to be scrapped because it wasn't going to give him the answer he wanted.
And how does the fishing line relate to LIGO?
I didn't know Jeranism.
LIGO. So please go back to LIGO.
What experiment at LIGO could you perform that would show that it is either A, not, or B, is perfectly straight, essentially?
So the only way that it's occurred to me to check if the LIGO tubes are straight or not is the fishing line experiment. I cannot imagine other experiment.
So what you want to do is you want to go and take like 6-inch PVC, cut it in half, put it on top of LIGO for the whole 2-mile length, fill it up with water, and then pull a fishing line across it.
Yes, kind of.
The first problem will be that I contend that it will actually have water only in the middle. You won't be able to get it to the ends if you keep the height the same off of it.
He would have to find a way to lay it directly on. Unfortunately, LIGO is not a smooth pipe.
Well, you wouldn't have to. I mean, you could offset it, stand it. Well, okay, I don't know what it looks like on the outside, but if it was one uniform surface and you kept it, let's say 10 inches off of the surface the whole length, it would actually have a hill of water in the middle. And it wouldn't prove anything because you would just say it curves up.
At best, he would come up with inconclusive results from his experiment. That's not going to work.
Yeah, and Tony brought up something in chat that I brought up earlier. How about a theodolite? That's how we did it in the first place.
Yeah, but the theodolite, it's
doesn't need water.
Light.
Yeah, but it doesn't need water.
Doesn't need water, but
he's going to say that it doesn't work because light does what he wants it to. Therefore, it's invalidated.
The theodolite is working with light, so. Anyway, the theodolite can reveal if the light is going straight or not.
Yep, it sure can.
The experiment I told you before, the German one, was doing this experiment with the theodolite.
Do you have any other accounts of that, or just the one experiment that shows these results?
No, just one.
Oh, just one.
So nothing. Size of one does not a flat Earth make or a concave Earth make.
Yeah.
Well, he doesn't believe in a flat Earth. He believes in a concave Earth. He's already established that.
Yeah, but regardless, a sample size of one does not a concave Earth make. If you're gonna say that one piece of evidence is enough, I have so much evidence that you're gonna be swimming for years to get to the rim.
So getting down to brass tacks, again, you got nothing.
Ignorance, incredulity, and paranoia.
Well, okay, I guess that's something. So yeah, you got those three. But you have no actual solid evidence. You have nothing to support anything that you've said. And yes, Pi, I did catch that.
But anyway, as you say, even if I do the fishing line experiment, if I do it right, and I got the result that the water is bending upward, you will say, no, it's not. This experiment is not effective because the line, when you stretch it, is changing density, and it's getting lighter. So that's why you got this experiment.
Oh, just for the sake of some of the YouTube comments, Robert, it's not a matter of being blind, it's a matter of a slam dunk. I basically want to just finish this off so that way I can just dismiss immediately in the future. So you've got no evidence, you've got conjecture, you don't even know what you claim to believe, even though your statements show that you believe in a concave Earth, not a flat Earth or a convex Earth. You have no basic understanding of mathematics. You have no basic understanding of physics. You have no understanding of material dynamics and material, what's the word I'm looking for? Properties. You basically, you've got nothing except and therefore anything you say beyond this point, we can just look at you and say, no, go away, get back on the porch with the little puppies, because you ain't running with the big dogs.
So what do you got? LIGO?
We've got LIGO, we've got satellites, we've got measurements, we've got pictures. We have every kind of evidence that you could want and dismiss without even looking into.
And mathematically, we have a set of models. We have a set of models that work together with each other parsimoniously
and provide predictive outcomes.
Okay.
And what have you got? You've got no model. You have conjectures. You have assertions. You have wild, yank it out your ass bullshit that you're throwing onto the table.
All right. It's my opinions.
That's all it is your opinions. No evidence, nothing backing it up. It's hollow. It's a paper tiger. Hell, it's not even a paper tiger. It's a paper hamster.
So remember, opinions are like assholes. Everyone's got one, and most of them stink.
Not mine. Mine's so clean you can eat off of it.
Yeah, mine smells like roses.
Unpaid shield. Let me ask you a question, please. Why that nickname? Why unpaid?
Why unpaid? Because I think it's hilarious that people on your side of the fence like to say, oh, they're a paid shill. They're a paid shill. You know what? I am not a paid shill. I am a retired old man that used to drive a freaking taxi, that dropped out of school, has no formal education beyond the second grade. And you know what? I'm sick of people that don't want to educate themselves, that don't want to become better, that don't want to learn about the world around them, that don't want to believe in the truth, that want to plug their eyes or plug their ears, shut their eyes, and spend their life going, la, 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 la. Because you know what? Those are the people that drag societies down and turn places into dark ages over and over and over. And frankly, I'm sick of people like that trying to wreck our children, wreck our society, and drag us back into Stone Age. That's why I'm unfreaking paid.
But shields? Are you shield?
He just explained it to you.
It's a joke at your expense.
Oh, okay.
They accuse anybody who has a good story of being a shill.
Thank you,
playing into
unpaid
that.
shields.
Now, I want to ask you, why do you have a name, I Got Questions, when you don't give a fuck about the answers?
That's why, because I only got questions.
Questions without using logic and reason are useless.
You're essentially a 3-year-old asking why at everything. It doesn't do any good because you're not going to comprehend a full answer. Also, Shill, is it? You were the one that's part of the 5 civilized tribes with me, right?
Correct.
All right, sorry, I just had to double check that. I've slept since.
Yep, that's me.
All right, good deal.
Oh yeah, smart. I know. And the message ain't just for this one, it's for all of them out there. There's a reason I'm doing this. It's because it's a passion of mine.
So, unpaid shield, if you're doing for passion, why are you get mad?
I don't get mad. I get passionate. When I get mad, there's an ambulance involved. And I don't get mad. I haven't been mad in decades.
Okay. Have you any person around you that you meet that it's a flat Earth or a concave Earth? I mean,
I have
not
not
on
met a
internet,
single one in
but
my life.
None still living.
I went on a date with a flat earther.
Wow.
Like, she actually had it in her Tinder profile. I think the Earth is flat. We went on a date, and I'll be damned if she wasn't kidding. She thought the Earth was flat.
Unpaid shield, have you been on any flat Earth meeting or something?
Have you studied science or mathematics?
Why are you answering with another question?
Why are you asking a silly question?
Yeah, it seems like a fair turn of play, considering you don't care about the answers. Why not just ask a question instead?
Bingo.
Yeah, I care about the answers, but
why does it seem like you don't?
One thing is caring about the answer, and the other thing is accepting the answer as the truth.
Then why don't you even give consideration to our answers, at least visibly?
Oh, I get consideration, but
can you demonstrate any consideration you give into anything we've said? Because really, it's all been immediately met with "nuh-uh" and they're lying. So can you please give me a demonstration of you considering anything we've said?
How could I do this?
Is there anything we said to you that was thought-provoking?
Yeah.
Can you give me one example of it?
Yeah. So Unpaid Shield said that if you stretch a line, could happen some molecular changes, and that molecular changes could provoke any changes on the density, right? So I'm thinking on it as a possibility, right? But I don't accept it as a fact, as the truth, right? So what I'm trying to say is, before that explanation, I didn't thought that a line could change the density, but now I considering as a possibility.
Yet you still wanted to argue, but then why did you want to argue as though it wouldn't?
No, I didn't understand, sorry.
Then why did you argue as though it wouldn't?
No, I just, but you don't listen, so you can.
Man, that's the Klingon calling the Cardassian bumpy.
This is got recorded. You can check it. I didn't say it's not like he says. I just said
no. You said imagine that I have a line that violates material science, and I wasn't willing to grant you that. But that's
no. I didn't say that violates anything. I just said imagine that I have a fishing line that is not changing density.
Yes, I don't understand. I don't see if you know the difference between what I said and what you said, but they're the same thing. You would be asking me to grant you a magic piece of line.
Okay, so semantic. Let me answer. If you got an iron an iron line and you stretch it, right? It's gonna change the density.
Say locally, depending upon a number of factors, yes.
It's gonna change an iron. It's gonna change density.
You realize that most metals have fluid dynamic behavior in some way. So if you leave them for too long, they'll tend to settle with denser spots, right? Not to mention that making a uniform dense piece of iron is practically impossible.
All right, so it has to be done. Any check.
I need another freaking drink. I'm glad I've got a lot of booze close by.
Until you can show me that you can make a uniform 100% density through and through piece of iron, and that it's not going to have sagging, material droppage, material settling or anything like that, you don't have a fucking leg to stand on, son. And on that note, I'm actually going to have to go. I'm sorry that I can't be here to slap you around some more. I wasn't meaning to be this abusive, but at this point, you practically earned it.
Yeah.
So, goodbye.
Yeah, that's the it's the end of this 750 ml bottle. And I just dropped my phone. So,
Okay.
do you have anything, honestly, seriously, do you have anything, or are you just going to continue blowing smoke at your ass?
Okay, thank you guys. I gotta go too.
Works for me.
Ciao.
Yep. Oh, dear God. And keep in mind, an atheist just said that. All right, Alan, where are we taking this? All right. Hey, it sounds like I'm the only person in here now. Damn, I've got a soapbox. Well, then, any questions from the YouTube audience that you want to post, or comments, or whatever? While I take another drink. He may have fallen asleep. Well, just to protect privacy, I went ahead and muted Alan. That way, in case somebody comes in and starts spouting off his address or phone number, nobody will hear it. And it sounds like this hangout has now pretty much run its course.
Yeah, I think we are getting there.
Oh, there he is.
Yeah, sorry. I dozed off a little.
I can't say as a blame you.
It's been a long day today.
That fella got kind of wearing.
Yeah. I think there was some hint that in the chat that he was a Poe.
Oh yeah, I pretty much had that figured out and decided that. But then when I saw other people saying the same thing, it was like, yeah, okay. At least I came to a similar conclusion. Soul Survivor. Where do babies come from? Well, when mommies and daddies love each other very much, they do this special dance called the horizontal mambo.
Yep.
All right. So you want to go ahead and do a wrap up, Alan?
Yeah. Well, I'm surprised that we've got quite so many people still watching us. But there you go.
It was a pretty good shit show.
We've still got 36 people watching, so that's really nice. I'm sorry.
Yeah.
I'm sorry it got in. I'm sorry it got interrupted partway through. The electricity proves to be.
Well, that's the way things go sometimes. You get someone in the panel that just wants to raise questions but not provide any sort of answer or give the other panelists any kind of due consideration, then you're going to wind up getting an interesting reaction.
Yeah. So anyway,
so I'll go ahead and mute myself, Alan. I'm gonna go ahead and turn this over to you now that you're kind of getting your head around into the real world again.
Yeah. Yep. Yeah. So thank you very much for everybody for coming. I am very glad that people do want to come and listen to us in these rather long and winding after shows. And I shall say good night to you all. And good night to everybody in YouTube land.